x whole to the power 1 upon 2 into x square minus 1 whole to the power minus 1 upon 4. Now you have to differentiate this function with respect to x. You can solve this problem by two ways. First of all, you can differentiate this function log. Suppose that this whole function is capital X, and you can differentiate this function with respect to capital X. Again, you have to take in denominator and again take numerator. In that case, you will think this is very complex function, because when you take in numerator and again differentiate with respect to x, in that case it will be very difficult for you. Why? Because it looks at very lengthy expression. So I will suggest you, first of all, try to simplify it using logarithmic property. As you know that this is first term, this is second term, and this is in product. Suppose that this is a, this is b. Log a into log a into b, log a into b. That's why can you write it? Log 2 minus x whole to the power 2 plus log x square minus 1 to the base 1 minus 1 upon 4. Now you will again tell me what is the base about this function. Both base, there is no mention base, so that's why you can use a base e. Don't worry by taking it. Now can you take 1 by 2 as a according to property of log, and you know that if there will be log x to the power m to the base e, you can write m times log x. Using this property, can I write here 1 upon 2 log 2 minus x? Similarly, can you write again here minus 1 upon 4 here, and it will be log x square minus 2. I think you understand very well. Now you can see this problem, it becomes very easy for you. Now you can differentiate this function directly. Can I write directly this function? Derivative of whole function with respect to x will be derivative of 1 upon 2 log 2 minus x minus 1 upon 4 log x square minus 1 with respect to which function? With respect to x. Now again I will tell you, when you differentiate this function and this function again, first of all, as you know that 1 upon 2 is a constant, so you can take out. I have already told you, if you differentiate c into fx or k into fx, where fx is function and k is any constant, pi 2 minus root 2, 5 by 7, as like it, there should be any value of k as a constant. In that case, while you are differentiating this function, that is k into fx, you can take k outer side of this derivative term, that means k times gf dx. You can write. So can I write here 1 upon 2 and derivative of 4? I want to again some steps so that it looks easy for you. Minus 1 upon 4 derivative of log x square minus 1 with respect to x. I think you understand properly. Now again see, I want to rub this part. Everything is very clear for you. Now see here, as you know that it is 1 upon 2 into log 2 minus x. Log 2 minus x cannot be differentiated with respect to x. So I want to jump sometimes I will jump. So be careful by taking it. Log 2 minus x cannot be differentiated with respect to x. So first of all, you have to differentiate log 2 minus x with respect to 2 minus x. 2 minus x. Again, 2 minus x will go in numerator and you have to differentiate with respect to x. 2 minus x can be differentiated with respect to x. It is very clear, but I want to write directly. I think you will understand very easily. If you not understand, I will again write it. It looks very easy. Firstly, see here. Firstly, differentiate log 2 minus x with respect to which function? 2 minus x. In that case, it becomes 1 upon 2 minus x. I want to jump one step for you. And again, 2 minus x will go in numerator. If 2 minus x will go in numerator and you have to again differentiate with respect to x, in that case it becomes minus 1. Why? Because my derivative of 2 will be 0 and derivative of minus x will be minus 1 with respect to x. Now again minus 1 upon 4 into, what is the derivative of log x square minus 1 with respect to x? And you know that you cannot differentiate directly by comparing formula log x with respect to x. So that's why you have to firstly differentiate log x square minus 1 with respect to x square minus 1. Again you have to differentiate x square minus 1 with respect to x. Now if you differentiate log x square minus 1 with respect to x square minus 1, you will get 1 upon x square minus 1. And if you again differentiate x square minus 1 with respect to x, you will get what? Which is your correct answer. I think you understand very well. Now again I want to, if you couldn't understand it, I will explain it here. See here, derivative of log 10x. As you know that derivative of log 2 minus x, firstly differentiated with respect to 2 minus x, and 2 minus x is differentiated with respect to. Sometimes you have to manipulate in mind. Always do not wish to write in not that means in your page or in your notebook. Sometimes you have to calculate in your mind such that automatically your mind exercise. Here see here log 2 minus x with respect to x, in that case it becomes 1 upon 2 minus x, and this will be derivative of 2 minus x minus 1. You can see. Now again similarly here you can also write log x square minus 1, derivative of log x square minus 1 with respect to x square minus 1, again derivative of x square minus 1 with respect to x. This is your answer. Now see example 11, sorry 10th next question. See example 6. If you see example 6, y is equal to, there is given log root under x square plus 1 divided by cube root of 2 plus x. Now you will tell me how can you differentiate. It is also very easy. Use only quotient rule of log root under x square plus 1 minus log cube root of 2 plus x. Now as you know that this root represents 1 upon 2, whole power of 1 upon 2. So you can take 1 upon 2 outer side and log x square plus 1 minus this represents 2 plus x whole to the power 1 by 3. So you can take log 2 plus 1 upon 3 log 2 plus x. I think you understand properly. Now this is your y is equal to this function. Now you have to differentiate directly with respect to x. Can you write dy dx? I want to write directly. Can you write here? I am trying to go shortcut such that you will also go in your examination sentence. You can save during solving this kind of problem. See, it is very easy. Simply differentiate log with respect to it. It will be 1 upon x square plus 1. Again differentiate x square plus 1 with respect to x. It will be x minus 1 upon 3. You have to differentiate log 2 plus x with respect to 2 plus x. In that case it becomes 1 upon 2 plus x. Again you have to differentiate 2 plus x with respect to x. It will be 1. So don't worry. See here, I can write directly. We will not write here. But try to use only in your competitive examination. And when you see you have no proper time to solve this kind of problem, then you can go through as it is. Again similarly I want to 7. I think 7 has solved in your previous class, as so only it has added log. Otherwise everything is same in the as previous. Can you write derivative of here y is equal to log x plus root under x square plus 1, firstly differentiated with respect to x plus root under x square plus a square. Again see here, I have already solved this kind of problem, log x plus root under x square plus a square, and here you see you are looking, there is no enough space to write again. So I want to directly differentiate that function with respect to x. Now I want to write a derivative of log, suppose that this is capital X, in that suppose that this is capital X, in that case it becomes log capital X with respect to x. Definitely it will be 1 upon x plus root under x square plus a square. This is a derivative of this function. Again see here, derivative of this function with respect to x will be what? Derivative of x with respect to x will be 1 plus derivative of root x square plus a square with respect to, again you have to again differentiate. Now if you differentiate this function, that means root x square plus a square with respect to x, you can't differentiate this function with respect to x directly. So first of all you have to differentiate root x square plus a square with respect to x square plus a square. X square plus a square. When you differentiate this function, that means root x square plus a square with respect to x square plus a square, if you differentiate root x square plus a square with respect to x square plus a square, then it becomes 1 upon 2 root under x square plus a square into, again you have to differentiate x square plus a square with respect to x. In that case it becomes 2x and derivative of a square will be 0. So you can leave. Now it becomes 2 to cancel, and if you take its LCM it becomes simply 1 upon x plus root under x square plus a square into x plus root under x square plus a square divided by what? Divided by root under x square plus a square. Now you can tell me this both term cancel each other. Finally you will get 1 upon root under x square plus a square, which is your required answer of this problem. Now again see next problem. I think you can solve question 8 and 9 also, because question 8 and 9 both is easy, and 10 is also easy. Now I want to solve question 11. Question 11, that means 11. See here 11. Here there is given y equal to log x. Now you can tell me, sir, how can you differentiate this function? Because there is 3 terms of log. How can you solve this problem? First of all, you have to always treat there is always base e. This is confirmed for you. Now I want to again tell you, first of all, this is your outer function. This is your outer function. This log, you have to differentiate firstly this log. Don't worry by taking this term. What is this? Don't worry by taking this. Simply treat this is first log, and you have to differentiate log, and remains term suppose that p, and you have to differentiate log p with respect to p firstly. So I want to write differentiating on both sides. Firstly I want to write your total concept about it. Can you write log x with respect to x? But you cannot differentiate this function with respect to x directly. So you have to proceed as it log x. First of all, you have to differentiate with respect to this term. That means log x. For balancing, you have to take again this term in numerator. Now you have to differentiate log x with respect to which function? This log x. So it will be log x. Again you have to differentiate log x with respect to. I think you understand very well. Now derivative of log p. Derivative of log p with respect to p will be what? 1 upon p. What is the value of p? Value of p will be what? Log x. 1 upon p. This is p. This is p. Whole term is p. And this is also p. Derivative of log p with respect to p will be what? 1 upon p. What is p? P is log x. I think you understand. Now this is again log. This is outer function. And you have to differentiate this log with respect to this term. Suppose that this is q. Derivative of log q with respect to q will be what? 1 upon q. That means 1 upon q. What is q? Q is log x. Into. Now we have to differentiate log x with respect to x, which will be your. I think you understand. You can leave it here. Now see again next kind of problem. Problem 12, 13 and 14. All these problems are very good. See again 13, 14, sorry 12, 13, 14. First of all see 12. In 12 it is given y equal to log 2 log cos x with respect to. How can you solve this problem? It is also very easy for you. First of all, differentiate with respect to x. As you know that this is what you have to use here. Derivative of log x to the base a with respect to x will be 1 upon x into log a to the base a. This is your formula. Now you have to apply here. Derivative of log cos x with respect log x to the log cos x to the base 2 with respect to x. As you know that log x to the base a directly differentiated with respect to x. That's why I have to differentiate here log cos x with respect to 2 only directly firstly cos x, and again you have to differentiate cos x with respect to what? X. In that case it becomes 1 upon x. What is the value of x here by comparing? You can tell me 1 upon cos x and 1 upon x into log a. This is base has taken here a, and you have to take in base finally e. That means you can write again here log 2 to the base e. Now you have to differentiate this function again minus x. This is good problem. Now take question 13. In 13, it has given log y is equal to log 7, log 7x to the base 2. Now you have to differentiate. How can you differentiate? Similar way, you can proceed again. You have to firstly write here dy dx will be derivative of log x to the base 7 whole base 7. Again you have to differentiate x, but you can't differentiate with respect to x. You have to again go derivative of log x to the base 7. Firstly, which function? As you know that this is as this form, so you have to differentiate. In place of x, here what is this term is step x, so you have to firstly differentiate log x to the base 7. Again you have to differentiate log x to the base 7 with respect to x. This is your actual form. Now you have to differentiate using formula. Simply here you have to now formulate log. Suppose that this term is p. In that case, this becomes log p to the base 7. In that case, it becomes log p to the base 7. Oh. That answer will be 1 upon p. That means 1 upon p. What is p? Log x to the base 7 into log p to the base. That means log p. Here what is base? Here this is total I have taken, but there will be base e. You have to remember it. But here there is no base because this is just as a x as this x. This. Now again differentiate log x to the base 7. Sorry. Firstly, I have differentiated log x to the base 7. In that case, first will be 1 upon x into log a to the base c. Log a. What is a? What is a? See here. 7. 7 is a. So you have to write 7 to the base c into. Again differentiate log x to the base 7. In that case, again it will be 1 upon x. That means what is x? X is x into log a. What is a? 7 to the base. This you now if you want to write in a standard form, it becomes 1 upon x into log 7 to the base c whole square into log x to the base c, which is your correct answer. I think you understand. Actually, this using this formula sometimes you will feel it is more complicated. So you need a more practice on this topic for these kinds of problems. That's why I am leaving all problems to solve for you. I am only solving all those problems that helps to you. That means all different kinds of problems that helps to you solve your exercise completely. Now again take 14. If you see 14, here y is equal to given that log x to the base 2. Now I want to again tell you, if you see this problem, as you know that there are only two problems which has told you. First of all, log x to the base c, which has not mentioned a base, and second will be log x to the base a, where what is a? Is constant. But if you see this problem, in place of there is no base e, or there is no any term, that means there is totally given a variable. If you see, there is no any formula through which you can this problem, because either there should be e in base, or there is no. In that case, you will automatically understand there will be e, or if you go in second case, there should be base a. But if you see in this problem, there is nothing as it. There is no a. In that case, how can you proceed? Very interesting. See here. First of all, you have to write using a log property. Can you write log b to the base a is equal to 1 upon log a to the base b? Can you write? Be careful by taking this property of logarithm. Log b to the base a is equal to 1 upon log a to the base b. In that case, it becomes simply log x to the base 2. Now, I again tell you, if it becomes log x to the base 2, but in which one? 1 upon log x to the base 2. It will be in this form. Now, if you take, can you write as it? It is very trivial. Now, if you see y is equal to log x to the base 2 whole to the power minus 1. Now, you have to differentiate this function. In that case, firstly, you have to write here derivative of y with respect to x, which will be log x to the base 2 whole to the power minus 1 with respect to which? X. Again, you have to write here log log x to the base 2 whole to the power minus 1 with respect to which function? Firstly, can you tell me? I want to again revise your formula. If you see derivative, it looks at what? In which form function? Derivative of x to the power n with respect to x n into x to the power minus n minus 1. That means x is taken here. In place of x, what is there? What is it? Here given log x plus 2 is simply single term you have to treat. Simply single term you have to treat log x to the base t. Suppose that this is p. Suppose that for 1 second log x. So if you wish, I want to write here log x to the base t 2 is equal to p. In that case, it becomes p to the power minus 1. And as you know that p to the power minus 1 is as form x to the power n. In that case, you have to differentiate this function directly with respect to firstly p. So can I write here derivative of log x to the base 2 with whole to the power minus 1 with respect to firstly log x to the base 2. Again, you have to write here derivative of log x to the base 2 with respect to x. Have you understood? Now you can write here what is the formula? N into x to the power n minus 1. That means minus 1 into log x to the base 2 minus 1 minus 1. That means minus 1 n and again take minus 1. That means minus 2. That's why I have taken minus 2 into log x to the base 2. What is the value of it? It becomes simply 1 upon x log 2 base. Now, if you want to again write in standard form, it becomes as minus 1 upon x into log 2 to the base e. You can write here log 2 to the base e into, you can take in denominator because there is it's a power is minus 2. So can you write here log x to the base 2 whole to the power 2, which is your required answer. I think you understand very well this problem. Again, I want to see next problem and which of the following problems are important for you. I think 14 is easy, 13 is also easy, no need to prove it, and 12 is also easy. Now I want to take only 11. In question number 11, it has given that as a implicit function. Actually, this problem is relevant to implicit function. In your books, it has taken in this chapter. I think after 2 or 3 chapters, I will again discuss implicit function. But he has taken in this chapter again one problem which is relevant to implicit function. See here, example 11. Very easy this problem. It has given that y is equal to x log y. X log y. And you have to prove that x dy. You have to prove that x dy dx is equal to y square upon y minus x. How can you solve this problem? See here. You have to prove that x dy dx is equal to y square upon y minus x. First of all, there is simple clue behind it. See here. You have to find dy dx. Dy dx. But y is not completely expressed in the form of x. Y is not expressed completely in the form of x. In that case, how can you proceed? I always tell you, when you face, actually I have already told you this problem is relevant to implicit function, and when I am teaching about implicit function, it becomes very easy for you. But in this exercise, it is not mentioned about implicit function, still it has given here. So I will suggest you how can you solve it. Whenever there is given dependent and independent function as that way in which you cannot express dependent variable completely in the form of independent variable, that means independent variable completely in, that means I want to tell you, if you couldn't express y, that means y is what? Dependent variable in terms of x, that means x is what? Independent variable. That means if y is completely dependent of x, in that case you have to use simply differentiate on both sides. But here it has given that y and x and y y cannot express completely in the form of x. In that case, we have to differentiate on both sides. That means we have to apply dy dx on both sides. Right here, differentiating on both sides with respect to x. In that case, you will get derivative of y with respect to x and derivative of x log y with respect to x. I think you understand. Now here you have to, this is what? This is dy dx. Now if you see here, that implies that this is in product of two functions log y and x. First of all, this is first and this is second. Log y you have to take outer side and differentiate derivative of x with respect to x, which will be 1. So dot to right here plus. Now you have to take x outer side into differentiate log y with respect to x. But here if you see about this problem, log y plus x into log y cannot be differentiated with respect to x. That's why I have to differentiate log y with respect to y with respect to y firstly. Again you have to differentiate the y with respect to x. As you know that dy dx, that means y cannot be differentiated with respect to x. So I have written simply here. Now I want to write log y plus x into derivative of log y with respect to y will be what? 1 upon y into dy dx into dy dx into dy dx. I think you understand very well. Now if you see here, dy dx is equal to log y plus x upon y into dy dx. Log y plus x upon y into dy dx. I think you understand. Now again take this term out, this side, that means towards LHS. If you take this term LHS, you will get dy dx minus x upon y dy dx, x upon y dy dx, which will be what? Log y. If you take common dy dx, if you take common dy dx, you will get 1 upon xy dy dx, which will be what? Log y. Which will be what? Log y. Again, I want to rub this portion. If you take LCM of it, you will get y minus x by y dy dx, which will be what? Log y. Which will be what? Log y. That's why log y will be, that means dy dx will be y into log y into log y divided by y. Y into log y divided by what? Y minus x. Y minus x. Y minus x. I think you understand. Now see your problem. What has you have to prove? You have to prove x into dy dx, but you get dy dx is equal to this term. Now you have to simply multiply on both sides by x. If you multiply, you will get in LHS x dy dx. According to your problem, in LHS you have to prove the x dy dx is equal to y square upon y minus x, and in RHS you will get yx into log y by y minus x. But you have to prove in RHS y square upon y minus x. But you have get y into x into log y by y upon x. But if you see your problem, your actual problem is given y is equal to x log y. So in place of x log y can be used y. So I want to write y into y by y minus x. Finally it will be y square upon y minus x. That means x dy dx is equal to y square upon y minus x. You will learn about this kinds of problem in your implicit function problem. In this exercise, it has given forcefully and as to solve it. And if you see question 14, it has given that y is equal to log x, and at point 1 0 and e to the power 3 and 3. You have to find the gradient. Gradient means that you have to simply find dy dx, and you have to put value of abscissa, that means x coordinate, and ordinate, that means value of y. If it is required, you have to put. Now you have to solve a D. I think approximately all above problem are similar kinds. 1 or 2 problems are different kinds, and you have to solve again. In next class, I will discuss again derivative of exponential function. That means e to the power x. How can we differentiate derivative of differentiate e to the power x, or e to the power any function is given, or a to the power x when a is constant. In the next class, I will discuss about it. And next I will again discuss inverse trigonometric function. That's why I will again tell you, first of all you have to remember and write in particular page or different page all formula which is related to inverse trigonometric function. or if you have not remembered, remember all these formula, because during solving you have to, as soon as you write or able to write on your notes during solving, it becomes more easy for you. And in whole differentiability, that means whole derivative topics of inverse trigonometric function, you will get totally inverse trigonometric function, only simple derivative. That's why I am always telling you, first of all remember all inverse trigonometric function formula, otherwise you will get a lot of trouble in this chapter. Thanks all of you. In the next class I will again discuss with you. So now, welcome. Thanks all of you. Bye.